Hello and welcome. We are going to start a series in which I will try to cover all the chapters of class 12 first, then we will proceed with class 11. In today's video, we are going to learn about start with electrostatics. In that, first topic will be electric charge and field. Now, in this case, in this video, we are going to learn about electric charge, its properties, and all the details. Electric charge and its properties. After that, conductors, insulators, method of charging, Coulomb's law, one small experiment that is called as gold leaf electroscope, and then superposition principle. So, these topics we are going to cover in this video. So, let us start. So first of all, when we say electromagnetism, so basically electromagnetism is nothing but the combination of electrostatics and electrodynamics. Now electrostatics, as you can see by name, electro that means charge and static means at rest. So we study the behavior of charge which is at rest, that will come under the electrostatic condition, and when we study the behavior and properties of charge or its effect when charge is in motion, that will be coming under electrodynamics, right? So here in this case you can see the two charges are fixed, and due to that fixed charges whatever effect is there, that we will analyze in electrostatics, and when charges are moving, that we will study in case of electrodynamics. Okay, first of all, when we talk about origin of charges, so we know that all the materials are made of three fundamental particles, that is proton, neutron, and electron. Proton we consider as the smallest unit of positive charge. Now, behind this proton and electron, there is one story that related to Benjamin Franklin. He said that whatever objects are showing the behavior of attraction or repulsion, so they will have some element, and they named it like positive charge and negative charge. And later on, as science advanced, so they found that there are three types of particles, that is fundamental particles, that is proton, electron, and neutron. So proton is considered as the smallest unit of positive charge, means proton will have plus charge, and that value of charge will be equals to 1.6 into 10 to the power minus 19 coulomb. Neutrons are neutral, that means net charge will be how much? 0. And electrons are considered as negative charges, and we represent symbol as E minus, and protons as P plus, or in some books you will see E plus. That is nothing but the opposite of charge of electron, positive charge. Charge on electron will be minus 1.6 into 10 to the power minus 19 coulomb. SI unit of charge is coulomb, and we represent it with capital C. Simple basic things. Now, there are few properties of charge. First is charge is conserved, and second will be charge is quantized, and so on. So first, charge is conserved. So it says that for an isolated system, net charge remains constant, and electric charge is always conserved for the system. So suppose there are two systems we consider, one is rod and one is this cloth. When we rub them together, so some charged particles or electrons will get transferred from the cloth to this rod, and as it loses the electrons, so it will get positive charge, and the rod receives the charge, so it will become negatively charged like this. But if you consider this complete system, so whatever number of electrons and protons were there, net charge will be how much? 0 only, right? So that is nothing but conservation of charge. Next is charge is quantized or quantization of charge. So whenever we transfer the charge, suppose there are 10 number of electrons and 10 number of protons initially. Now some electrons are transferred from this rod to this cloth. So the number of electron that is transferred or charge that is transferred, that will be equals to n times of charge on electron, right? So charge is moving in quanta packets, so that's why we call it as quantization of charge. So the least possible value of charge that can be transferred is the charge of electron, which is equals to minus 1.6 into 10 power minus 19 coulomb, means charge of the electron. So when we rub silk cloth with the glass rod, there will be transfer of electrons, and net charge on the body is given by, we can just say that total charge will be equals to number of electrons that was transferred to or from the object. If charge is transferred to the object, electron is transferred to the object, so minus sign, otherwise plus sign. So plus minus ND. It is not possible that half of the electron is transferred, right? So these terms are not possible. This will be the charge Q, that is equals to plus minus ND. And value of N can be 1, 2, 3, 4, and so on, integer numbers. So an integer number of electrons can be transferred from one object to the another object. That is called as quantization of charge. Next property is like charges repel each other. If we bring two positive charges together close to each other, then there will be repulsive force acting between the charged particles. Similarly, if we bring two negative charges, so you can see by this image, so they are repelling each other. So repulsion will be in case of like charges. In case of unlike charges, when we bring plus and minus charges closer, so they will attract each other with the force. So that will be attractive force will be acting. So unlike charges attract each other. Simple. Next is uh, charge is having additive nature, or we can say we can find the net charge of the system by just adding them algebraic sum. So charge is a scalar quantity and additive in nature. Suppose in this system we consider this a system, and there are five charges like q1 plus q1 plus q2 minus q3 minus q4 and plus q5. So if you want to find net charge of this system, so we just add all the charges, that will be q1 plus q2 plus q3 and so on, and we can find the net charge with sign, if positive charge plus negative charge minus, right? Next, charge and mass. So in case of charge and mass, both are intrinsic property of the matter. Charge as well as mass. Intrinsic means inherent property. Now charges are a scalar quantity as well as mass is also a scalar quantity. Now charge can be positive and negative. Charge has two types, positive and negative charge, like electron and proton we had seen. And mass is always considered positive. Mass is always positive. Next is a charge exerts electrostatic force on another charge at a distance when there are two charges, point charges. So force of attraction or force of repulsion can be acting. Just now we had seen that when charges are of opposite nature, then attractive force will be acting. When charges are of same nature, like here plus charge and plus charge, in that case repulsion force will be acting. But in case of mass, we know from Newton's law that mass exerts gravitational force on another mass at a distance, and that will be the force of attraction between the two masses. Two masses always attract each other. There is no repulsive force in case of mass. Next is charge cannot exist without mass, because we know that charged particles are electron and proton. So both electron and proton are having mass. So charge cannot exist without the mass, and magnitude of charge is independent of its speed. Suppose the charged particle is moving with some speed that is almost equal to a speed of light. In that case also the charge value of charge will be same. But in case of mass can exist with the zero net charge, like we know neutron, there is no charge, so net charge will be zero or neutral bodies. But one more thing is magnitude of mass is not independent of its speed. These topics we will study more in the case of modern physics, when particles are moving with a speed that is relative to a speed of light. So in that case mass will be equals to m naught divided by root under 1 minus v by c square. So here when v is very small compared to c in our general cases, so this term will become how much? 0, and we get mass as m naught. But when this v, velocity of the object, suppose v it is moving with v equals to c by 2, in that case mass will not be the static equal to static mass. So it is speed dependent, right? So now few basic things, that is conductors and insulators. So what is conductors? We all know conductors are material in which the outer electrons of the atoms or molecules are only weakly bond to it. So conductors have electric charges, that means free electrons that are comparatively free to move inside the material. Second is when some charge is transferred to a conductor, it radially gets distributed over the entire surface of the conductor under electrostatic conditions. Suppose there is some conductor and we transfer some charge on it, so that charge gets equally transferred throughout the body. Free electrons are also known as conduction electrons. Example will be metals. So these are called as conductors. Insulators are the materials in which all the electrons are tightly bound, means there is no free electron. So if some charge is given to the insulator, it will stay at the same place. Example is lot of most of the non-metals like glass, porcelain, plastic, nylon, wood, all these are examples of insulators. Simple, easy. Next is method of charging. So method of charging will be charging by rubbing or friction. So when insulator materials rub against each other, they may become electrically charged. Like when you rub any two objects, like you comb hair, dry hair, in that case, comb gets charged and will start attracting the lighter objects towards it. Right? You have observed this. So electrons which are negatively charged may be rubbed off one material and onto the other material. Like here when we rub this cloth with the rod, so some of the electrons from the rod will get transferred to the cloth. So since cloth is accepting electrons, silk cloth, so this gets negative charge, and glass roll will get, it has lack of electron, it has transferred electron to cloth, so it gets positively charged. So by rubbing we can transfer electron from one object to another and we can get the object's charge. So materials that gain electrons becomes negative charge, and the net charge of the system like silk cloth plus glass will remain constant. If you consider net charge, whatever was the exchange of electron to or from both of them, that will be same for the system, right? So net charge will remain constant. Next is charging by conduction. So charging by conduction involves the contact of a charged object with a neutral object. So in this case, we can obvious when we bring the two objects in contact, that means both should be conductors only. So here we bring one charged metal rod which is negatively charged in contact with neutral object, and this will be insulating stand, right? Otherwise electrons get transferred to the earth. So here now when we bring them in contact, so some of electrons get transferred to the neutral body and both will get same charge. So both conductors will be charged with the same type of charge when charged by conduction, and charging by conduction is only possible in case of conductors. In case of all metals, right? The net charge is distributed between the objects and the net charge of the system remains conserved. So net charge of the system in this case also will be constant. Next is charging by induction. So using this method, a neutral body can be charged without actually touching another charged object. In this case, we bring one charged particle closer to one neutral particle without touching them. Now this charged particle can be metal or non-metal because we are not transferring charge by contact, and this particle or object on which we try to induce charge, that must be metal. So here now we know that when we bring one charge particle near to the neutral body will have plus and minus charge randomly oriented, and once the charged particles come near to this, so what happens, this is metal, so they have free electrons, so all the electrons will move away if it is negative charge, so electrons will accumulate on the further side, and at the closure side there is lack of electrons, so plus charge will induce. So free electrons can move from one place to another in the metal, and free electrons inside the conductor move out to the surface to create surface charge. Charging by induction is only possible in case of conductors because they only have free electrons, right? So in this case, what we do is, we have two neutral conductors, we bring them in contact, and now bring one charged particle. In this case, we brought one positive charge. So without touching them, when you bring it closer, so all the electrons from the other neutral object also get attracted towards this charge, right? And we know that free electrons can move throughout the surface, so they will accumulate on this side, and on the other metal there will be lack of electrons, so plus charge will induce, right? Now, next is without moving this charge, we will separate them. So, in this case, without removing this, now separate them. So, once you separate, so whatever charge was came on electrons came on the this conductor, that gets trapped, and here there is a conductor negative charge, so sorry, plus charge, so all these electrons are now trapped, we have separated them, and now they get charged. So here negative charge will appear on this part and positive charge on the other metal. So in every method of charging, net charge of the isolated system will be how much? Constant only. So these were properties of charge, very basic things, but very important, because most of the time they will ask you the questions based on charge, especially in case of JEE main or NEET. Next is now Coulomb's law of electrostatic, very important topic. So let us start. So Coulomb's law is, we can say it is one copy paste kind of thing from the Newton's law of gravitation. So Coulomb's law said that the magnitude of electrostatic force between the 2 point charge is directly proportional to the product of the charge. What Newton said was force was proportional to product of mass, and it was proportional to 1 by r square. Similarly, here Coulomb said that the force is directly proportional to the product of charge and inversely proportional to a square of the separation distance between them. So here now force we can say that will be proportional to q1 q2, and it is also proportional to 1 by r square. So we can combine them and we can say that magnitude of force that will be equals to k q1 q2 by r square. Here k is some constant, right? Simple, easy. R will be separation between the two charge particle, and we know that when we have unlike charges like minus charge and plus charge, so force of attraction will act, and when we have plus charge or minus charge, same nature of charge, then repulsive force will act, right? So in case of a pair of charges, there are some properties of Coulomb's law, we can say, or characteristics of Coulomb's law. So the main formula is F equals to K Q1 Q2 by R square. So in case of pair of charge, they exert same amount of force on each other. So whatever force is exerted by one particle, charge particle, same force will be exerted by the other charge particle. Direction will be opposite, of course. So electrostatic force acts in opposite direction. Their magnitude are same. Electrostatic force always act along the line joining the two charged particles. Electrostatic force form an action reaction pair. What is action reaction pair or Newton's third law? Action reaction pairs are forces which are equal in magnitude, opposite in direction, and acting on the two opposite objects, two different objects, sorry, two different objects. So in this case, they are acting on two different objects. Their natures are same, magnitude are same, direction is opposite, so they form action reaction pair, right? Next is electrostatic force can behave as a central force. Central force is when force is acting along the line joining, or we can say along a fixed point. Suppose this charge starts moving, so in that case force will be towards or away, means along a line joining these two charged particles. So those are called as central force. Next is electrostatic force between two charges depend on the medium in which they are placed. So electrostatic force. So here they have asked 2-3 times the question on electrostatic force acting between the two charged particles. Suppose there are two charged particle plus charge and another charge is minus charge. These two charged particles are placed in water. If they ask you net charge, net force, so net force will depend on the medium. But if they ask you force due to each other, force due to each other, so that is independent of medium. That is independent of medium. So force due to each other will be independent of medium, but net force on the particles will change. So what happens is, suppose there is water, so in this case water molecules will get polarized. So this will become minus charge, minus charge, plus charge, minus plus, minus plus, like this and so on. So there will be net negative charge on this side and there will be net positive charge on this side. So due to this now, one force which will be opposite in direction will induce between them. So here plus charge, here minus charge, so some force will be acting in this direction, and due to which net force will get changed. So Coulomb's law's property, that is proportionality constant K. What is K? We seen that F is K Q1 Q2 by R square. So what is K? So K is called as proportionality constant and its value is K equals to 1 upon 4 pi epsilon naught, and its value will be 9 into 10 to the power 9, and unit will be Newton meter square per Coulomb square. No need to mug up the units or dimension, they may ask. So here you have F equals to K Q1 Q2 by R square. So from here you can write K will be equals to F into R square divided by Q1 Q2. So Newton R square meter square per Coulomb square. Simple. Epsilon naught is called as permittivity of the free space. Permittivity we can relate like how much the medium allows the two charges to interact. That is called as permittivity of free space. And in case of vacuum or air, it is around 9 into 10 power minus 12. So you can remember it like 9 into 10 to the power minus 12, or exact value is 8.85 into 10 power minus 12 Coulomb square per Newton meter square. Simple, easy. So value of K is 9 into 10 to the power 9 for air or vacuum. Now one small experiment is called as gold leaf electroscope. So in this case what happens is there is one jar in which we connect one metal leaf. You can use aluminum foil also, which is available almost in all households. So aluminum foil you can connect with one metal rod, and here now one disc you can connect. Some coin you can place. And now you bring one another charged particle near to this. Now suppose initially it was neutral and we brought one plus charge. So what will happen? All minus charge will come here and plus charge will move away. So due to this motion, the separation between the gold leaf will increase. Or suppose we bring it in contact, so plus charge will be there throughout the metals. Now remove this plus charge and we bring one minus charge closer without touching them. So all this plus charge will go down and separation between the gold leaf will again increase. So like this it works. So gold leaf electroscope is sensitive electroscope type that is used for detecting the charges. Now construction will be, it consists of the brass rod with a brass disc at the top, and at the bottom there are two thin gold leaves in the form of foil. At the lower portion of the jar, a thin aluminum foil is connected. This aluminum foil will be connected. The aluminum foil is grounded, this part. This part is connected so that if suppose there is some charge on the bottle or this glass jar, so that charge will be, whatever extra charge, some disturbance is there, so that will be moved down by this earthing. So aluminum foil is grounded with the help of a copper wire so that the leaves are protected from the external electrical disruptions. Now, it works on the principle of charging by induction. So we'll bring one charged particle here. So a positive charged particle is brought near the metal cap. Then an unknown body is brought near the metal cap. Suppose we bring one positive charge. So due to that, positive charge will be there on gold leaf and on the wire. Now on this there is some charge, we don't know the nature of charge, but we brought it. So when we bring this charge particle near to this, so suppose if both are positive only, so these positive charge particles will move down and charge on the metal leaves will increase, right? So as charge increases, so separation between the gold leaf will also increase. But suppose if charge is negative, hope you are getting these points. So charge is negative, then all these plus charge will move up and charge, net charge on the gold leaf will decrease, right? So net charge decreases, that means force will decrease and they will move closer. So by that we can identify the charge on the body. So if the leaves divert further, we conclude that the unknown body has the positive charge because initially we charged the gold leaf with positive charge. If the leaves comes closer, then we can say that charge on the unknown body is negative. Like this we can identify. However, if no further divergence takes place, then we can say that body has no net charge, right? So now, so application of gold leaf electroscope will be detect charges, identification of the nature of the charge, identification of body as a conductor or an insulator. So by this we can identify the charge, nature of charge. So this is the way how we use gold leaf. So here now there is one neutral gold leaf and you can see one metal rod having negative charge we bring near the metal cap. So all positive charge will move up and negative charge will be on gold leaves. So now net charge on gold leaf is higher, having same nature, so they will move apart, and like this we can detect the nature of charges. In this case it was neutral only. So once we bring in contact with the metal, so charge will be same on both of them. Now next time when you bring any charge particle, so we can detect the nature of charge. Next is property of Coulomb's law. So electrostatic force of interaction between the two charges is charge in consideration is independent of the presence of other charges. Means we can say if there these two are in some relation, so if some third person comes, there will be no effect on their relation. But in real life, that is not possible, right? So here now, whatever force was exerted by on first charge by second charge, whether third charge is there or not, these charges will forces will remain same. Their interaction will remain same. So force 2 on 1 will be equals to force on 1 due to 2. Similarly, force on third due to 1 and force on first due to third, that will be same. Now Coulomb's law in vector form, since force is a vector quantity, so we can write Coulomb's law in vector form is, suppose we have two charges q1 and q2. So r1 is position vector of q1 and r2 is position vector of q2. So we can say that r vector that will be equals to r2 minus r1. So position vector of q2 with respect to q1. Now magnitude of force on q2, on this charge we want to find force due to this q1 particle, right? So here force will be equals to k q1 q2 by r square. So direction, we know that direction of F12 is same as r if q1 and q2 both are of the same nature. Suppose both are positive, then force will be repulsive. So direction of force and direction of r vector, that will be same. And if both are having opposite sign, suppose this was negative, so direction of force will be opposite of the r vector, right? So direction of force on 1 due to 2 is opposite of r if q1 and q2 are of the same nature, right? Next is, so in vector form if you want to write, so we can say that force on 2 due to 1, that will be equals to k q1 q2 by r square if both are having the same nature, and r cap will be the r direction of force. So if you use r cap, then r square, and force on 1 2 due to 1, that will be k q1 q2 by r square and r vector divided by magnitude of r vector. So that will be equals to, see, when we write r vector r cap, that is nothing but r vector by magnitude of r vector, right? So both are same. R is a unit vector directed from q1 to q2. So in vector form we can write Coulomb law, force on 2 due to 1, that will be k q1 q2 by rq r vector, and r vector will be r21, same order, r2 minus r1. So we can substitute the values of charge q1 and q2 with sign. If they are having the same sign, then they will become positive. If they are having sign negative, opposite, so then direction of force will be opposite of r vector, that will take care, right? Now superposition principle is when there are a lot of charges present and we want to find force on one charge particle due to all other charge particles. So force on any charge due to number of charge particles will be vector sum of all the electrostatic force on that charge due to other charges taken one at a time. So we can say that F net that will be equals to force on first particle due to 2, 3 and so on. And since force is vector quantity, so we need to add them vector addition. Simple. So let us solve one very simple question. Question says that a system of two bodies A and B of mass 2 kg and 4 kg respectively having equal charges 2 coulomb on them. So find the speed of A at t second if speed of B is 20 meter per second at that instant, and take the system to be at rest initially. So here we have two charged particles 2 coulomb and their masses are 2 kg and 4 kg. Initially they were at rest at t equal to 0. So when at some time t, their speed of b is 20 meter per second. So b is now, this is b. So b is now moving with 20 meter per second. So speed of a will be how much? This v will be how much? How to find? So in this case, separation between them is not given. Time is also given as t only. So if you think like force we can find, then we can find acceleration, then find velocity. That will be very lengthy and very uh, complex thing we can say. So in this case, what we can see is you can observe that these forces are, if you consider both of them as the system, so F external will be how much? 0, and we know that whenever F external is 0, so we can say that momentum initial will be equals to momentum final, right? Momentum initial was how much? 0, and final will be equals to 2 into V moving in opposite direction, so minus sign plus 4 into 20. So from here we can say that V will be equals to 4 into 20 by 2. So that will be equals to 40 meter per second. Yes or no? Simple. And direction is opposite. We have already considered. So we got in positive sign. Otherwise, if you consider here plus, so it will become minus. That means whatever we assume direction, it is opposite of that. Simple, easy. So at net external force acting on the system is 0. Its net linear momentum must be conserved. Initial momentum will be equals to final momentum. So we can simplify and we got the value as 40 meter per second opposite of the B. Simple. So this is it. Thanks for watching and we'll continue this series. Thank you. Bye bye.